Welcome. In this tutorial, I'm going to start the first part of section 12, the wireless networking. It's very intensive, but it's not as challenging as it may seem, and I'm going to do the very best that I can to explain each and every part for you. So you can see right over here, we're going to start off with wireless concepts. And at this point in time, wireless is pretty much what you're used to. There's just basically two different types. There's the home and then there's the business. So we're going to touch on both of them. So the very first term you want to know is what a station is. And basically, a station is anything that has a network card in it, a wireless network card, or even a regular network card. However, the wireless ones are obviously the ones that you need to hook up to a wireless network, whereas a wired one is only going to hook up to a wired network. You already know that. So then we have an access point. An access point is nothing more than something that a wireless computer, laptop, a iPad can connect to and be able to access network resources. And it could either be one sitting on your desk or it could be one hanging in the ceiling. Then we have what is called BSS, or Basic Service Set. And what that is, it's really called also a cell. It's the smallest unit of the wireless network. And basically what it is, it's the devices communicate through the BSS to each other. And depending upon the operating mood, all of them are going to operate on the same radio frequency channel in order to communicate. If they're on different channels, then obviously they're not going to be able to communicate. Then we have an independent basic service set. And that's, basically that is the combination of all these things that get put together. So you can see that how it all plays together in the next slide over here. Then we have an extended service set, and that's used to consist of multiple BSS with a distribution system. And basically the ESS is a combination of multiple BSS that are going to be able to overlap and be able to set up how you're going to be able to connect when you walk from one area to another area. And the DSS, as I talked about in the last slide, is the backbone of the LAN. It connects all the multiple APs and BSS, and the DSS wireless clients work together. Then they're going to communicate through the wired network and with other wireless clients on the cells. It sounds like a lot of mumbo jumbo, but basically the slides will show you exactly what it is. And what you're familiar with the most is the SSID. When you go into Starbucks or to the airport or you go into work, it's going to be a network identifier, and that's called the SSID. Then you also have a BSSID, and that's actually, in case you want to know, 48 bits, and it's going to identify the IP and the infrastructure. So for an ad hoc, that's very important. And it also allows you to connect to a specific IP, an AP inside the ESS, that's going to obviously have more than one access point. Basically, the BSSID is the MAC address of the AP, and it's automatically set. So again, then we have radio frequency wireless. Basically, we're going to be talking about 2.4 and 5.75. So you can see that there are multiple 5s. There's 5.8, 5.15, 5.25, and 5.725. We're going to be dealing with 5.7 to keep it simple. So then we have the 2.4s over here. You can see it's broken up into 11 channels, and each one of them overlaps another channel, which we're going to talk more about that later on. Then you have the spread spectrum, SSS, and we'll see how that works in the next slide over here. So using spread spectrum, the radio transmitter on a computer is really going to vary the frequency it's used to transmit. So in other words, what that means is it's just spread across a wide band of frequencies. And what that will allow you to do is spread it over multiple channels, which of course is going to increase the throughput. Then you have FHSS, and that's called frequency hopping spread spectrum technology. And basically it uses just one frequency at a time. However, it's going to change that frequency that it uses each second. So what will happen is the transmitter is going to begin transmitting on one frequency for just a few milliseconds, and then it's going to hop and change using another frequency. Then after a few seconds, it'll change to something else. Then it'll change to something else again. So it's going to hop from one. So you can see in the slide that it's using the different frequencies in order to transmit. Now we have DSS, or direct sequence spread spectrum, and it's really similar to frequency hopping, but it's just slightly different. The transmitter, in this case, takes a piece of information, divides it into chunks, and spreads the chunks across all of the frequencies, and then sends them all at one time. So it really increases the bandwidth. So now we have an optional frequency division multiplexing. Try to say that. That's really challenging. You can see in this slide over here, you have a computer, and technology and radio frequency is bouncing off of walls, and sometimes it's called a ghost signal, which is really nothing more a duplicate of a signal, but it's just delayed a little bit. So this was designed to address the issues encountered wireless networks where multiple reflected copies of the range signals received by the receiver. So what's going to happen, the reflections are created when the radio signal bounces off an environmental obstacle such as a wall or even an entire building. So you can see how this works. So it breaks it up into small data streams in here. So here's how exactly that it works. So if you have a wheelbarrow and you're trying to wheel all the bricks at one time, and you encounter an obstacle such as a little gully in here, and the wheel gets stuck, because it's so heavy, there's so much in there, it's very difficult for you to move that wheelbarrow. But if you have multiple wheelbarrows with just a lighter load, and then you step in that same gully, it's much, much easier to get out. So it really breaks the data transmission into very small data streams. And then we have it again for A, G, and N, basically the same. So here we have the frequency ranges. We talked about FHSS, DSSS, and OFDM in summary. Then we have wireless architecture. And again, that's pretty much what you've already been used to. So in station, we have a station over here. We have a BSS. So a station with a wireless network card is often called an SDA, or station. Sometimes referred to the station as the host, but it's the wireless network interface on the host. So we have two different types of operation. First one is ad hoc. So you can see how the devices are configured to communicate directly to each other. And you saw the mesh technology in our previous sections over here for the network infrastructure. And here you can see it in the wireless infrastructure, how they all communicate with each other. The second mode is really what you're probably used to, and that's the infrastructure that uses a wireless access point, or a WAP. And sometimes it's just called an AP. The wireless access point really just acts nothing more like an Ethernet hub or a switch, and you can see that it's using the star topology. So again, we have the smallest network unit in the network is called BSS, and it's just a basic service set. And all it is, again, we said before, it's a collection of devices that communicate together using the same channel. So obviously everything in this one, the two stations and the WAP, are going to use the same channel. So now we have something a little bit different here. We have a collection of multiple basic service sets. It's referred to as an ESS, or extended service set. So you can see it's identified by a name that's similar to the SSID. So the configuration here allows wireless hosts in one BSS to roam or move to another one. So here you have the laptop. It's going from one section to another. If you have a building and they're all on the wireless, and you might have several floors, you can go from one to the other without having to log out and log back in. We talked about this before, the carrier sense multiple access, and of course collision avoidance. And what you're doing is you're looking for, computer A is ready to send, so it's telling everybody, hey, I'm ready to send. So then at this point in time, B sends out a you're clear to send. Then the next thing it's going to do, it'll send, and then B gets acknowledgement that we got it. So these are the summary things for you to know about, and it gives some questions that you might want to ponder over. So now we have wireless standards. Okay, again, there's two types of standards. The 802.11 for wireless network is really what you want to know about. So what you really want to do is pay special attention to the frequency, the speed, the distance, the number of channels, and compatibility with other standards. So here we have multiple input, multiple output, and that's nothing more than an access point that has several antennas that you can communicate through each one. You can have up to 4, and you can actually have some doing input and some doing output. And here we have channel bonding. Channel bonding combines the 2 non-overlapping channels. Then you're going to just do it into a single channel. Just think of it as combining a lane into 2 separate lanes, so you can get cars going in lane A and lane B. Basically the same thing. However, it's important to understand that in order to use that, the access device must be able to accommodate channel bonding. So what you're going to do is you're going to have a 20 megahertz channel, and you're going to have 2 of them bonded together, so you're actually going to have a 40 megahertz channel. Okay, multi-user MIMO or MIMO. It's enhancement to MIMO that allows multiple users to use the same channel. In addition, it's going to be 802.11 AC, which doubles the number of MIMO radio streams from 4 to 8. And here we have some more wireless standards. So you can see A and N use 5.75 and B and G use 2.4. One of the problems with 2.4 is you can see it can have interference with other wireless devices, such as a cordless phone. Even a microwave oven can do that. And then you have compatibility issues. Well, B and G can communicate with each other, but B can't communicate with A because they're on a different frequency. The one good thing about N is they're usually backward compatible, so you can set it into mode where it can communicate with both B and G as well, but obviously would have to be at 2.4. So you can see again, these are the speeds and the distance and the frequencies that the different protocols are able to accomplish. So I want to emphasize speed and distance are a factor in each wireless. So you can see each one of them is a max speed. That means the most you're going to get. In reality, you're probably not going to get anything that high. Here we have some channels over here and how they work. So basically a channel is nothing more than accomplishes a defined portion of the wireless radio frequency by the range. So what you're doing is you're dividing a frequency rate into channels, and they're overlapping channels that can coexist in the same list translation, transferring data at the same time, but without interfering with each other. So what we need here is the non-overlapping channels, which you're going to see in here. So the 2.4 is going to have 11 channels. What we want to do is take out the non-overlapping ones, which is 1, 6, and 11. The number of channels is really available. It's dependent upon the frequency range your wireless network is using. So the 2.4 gigahertz frequency is divided into 11 channels. And because there are 11 channels, you might assume that it can implement up to 11 wireless networks in one location. Unfortunately, that's not going to happen because they overlap. So if you're using 1 and 2, part of 1 is going to be shared with part of 2, which means if you're communicating on channel 1 and 2 at the same time, you're going to have some interference. So here we have the number of channels available is again, depends upon your frequency range. The 2.4's got 11 channels, and of course there's 11 channels. You might again assume implement in here, but basically this is saying the same thing over and over and over again. Do not assume that you can do that because they're overlapping. So I just kind of repeated myself in here. So multiple channels on your access point, you can configure some radios to transmit on different frequencies. So this would be a 802.11n. You have the multiple channels. So now you have 4 antennas, and you can do a 2 and 2.4, 2 at 5.75, or however way you want to do it. That'll let you be backwards compatible with B and G. And then the MIMO is going to allow the antenna to access device streams into multiple devices, so you can see exactly what we're doing over here, and they're pointing them in different directions. Channel bonding we talked about, so we're going to take channels 1 and 6, and that's going to upgrade them into one larger channel. So you can see over here, we're going from 54 megabits to 108 megabits. And then, of course, in the 5.75, you have more channels to take over. You have 23 channels instead of just 11. So now we're going to talk about infrared. And infrared is kind of on its way out, but it's, you know, still places here and there you're going to find it. Two types, the near and far, the IRDA. So, you know, some of the infrareds used to be with mice, with printers and things of that nature, but it's really being taken over by Blueprint. So you have the line of sight over here. With line of sight, it's got to actually be together. Just like you point your remote to something, your remote control TV, if you're not pointing it directly to your TV, it's not going to change the channel. And it uses infrared, uses a pulse of light to send data. So it's kind of like fiber optic, but fiber optic is enclosed. And these things here you want to use, they're going to be near, intermediate, or far, but basically most of them are going to be very close over here. Now we have another one. We have the sight over here. Notice how if it's not lined up, it's not going to be able to communicate. Then we also have another issue, which is a wall. So now we're losing our ability to communicate if it can't get through the wall. If you have a computer and you're going to actually communicate, you're going to need to have a special cable. However, in this slide, you're seeing one that actually diffuses and makes the transmission go cone shape, and it spreads it out over here. This is the adapter that I was talking about. If you have a computer and you want to use an infrared device, you're going to need a adapter through the USB. Okay, Bluetooth is what we're really pretty much up to. You go to the gym, you see everybody with Bluetooth headphones on. I wear Bluetooth headphones on. I don't want to be tied up to the different cables in here, especially if I use my iPad that has one type of connector. My phone has a different type of connector. So I can't use the same headphones with one, but my Bluetooth will work just fine with both of them over here. So really, Bluetooth is defined in the 802.15 standard. It uses radio waves in the 2.4, 2.5 REN, and like infrared, they're intended for short communications, really short. Depending upon implementation, you can have a maximum of 100 mediums between it. That's kind of far, but that's a maximum in here. So there's 4 standards over here: the 802.15, the 1, 2, and then the 3 and 4. It's important to note that the 3 and 4 are a little bit different how they do, and they're up to 24 megabits, but they're actually using the 802.11 standard link. Here we have what's called a PAN, a personal area network. So you have one device, and that's controlling headphones, it's controlling printers, it's controlling a game console, it's controlling your phone, and a pair of permanent speakers in here. Okay, now we have some NFC communication implementation modes. Card emulation is probably the one that you're used to seeing the most when you go to the movies or you go to a sporting event and you have your ticket. They just take this little device and it scans it right then and there. In order to do that, they have to be very close, just a few centimeters away. And then you have obviously peer-to-peer and a reader-writer. So we talked about the card emulator in this room over here. Okay, next is peer-to-peer. So really it allows 2 different NFC devices to establish a link and exchange data directly, and that's going to be doing it through half duplex. And the final one is reader-writer, and that allows native RFID like your mobile phone or tablet to read information from a passive NFC device like some kind of tag in there. And here is a discussion in here, and then we have the wireless configuration. So here we have a home wireless network. We want to create one, we want to secure one, and we want to configure the profiles. Profiles are really easy to configure. So again, we need an access point, And the access point could be something that you get from Comcast or from AT&T. So these are consumer grade. You can even go to Best Buy and pick one, or Office Depot. However, they're not designed for large organizations. You really want to have 3 or 4 in there. Anything more than 7 is probably not going to work over here. So you're going to get to connect to it through an IP address, such as 192.168.0.1. You go in there. It may have a default password. Most of the time, it's just plain admin and no password, or admin and password that will get in. Of course, you're going to want to change the password so somebody else can't get in here. So the first thing that you're going to do is you're going to set the region. Now that doesn't happen in every single device. It may already be set for you, but if you have to set the region, basically it just wants to know what mode are you going to use, 2.4 or 5 gigahertz. You also, that's the node. The region is going to be what frequencies you're going to use, your AP can use. However, remember that you may not be able to change it later on once you set it. Then you have the channel width. You're going to set up whether it's going to be 20 or 40 degrees, the channel itself. Of course, you want to change the default SSID. Your security. Use WPA2 Personal or WPA2 PSK. That's just pre-shared key. They're the same thing. It's going to give you a passcode. Then the authentication is the actual passphrase or in there. However, if you're using WPA2 Enterprise, then of course you're going to need a radio server. Then we have MAC filtering, which allows you to limit the MAC addresses of devices that can be used. However, be very careful, because a lot of people think, well, if I limit that to MAC filtering, then only these devices can attach, which is actually true. However, there are people that drive around and they're able to find out a MAC address, and then they can change the MAC address on their computer as well. So be very careful about that. Okay, here you have a network wireless configuration. Everything is going through one access point, which is acting like a switch in here. So what you're going to do here also, if you're setting up a wireless network, you might need to install drivers. If you're doing a wireless network card, you obviously need to have a network adapter. You need to set up your security, your encryption type, and the key. And if you're using WPS to auto connect, which I don't recommend, it's not as secure. However, you can do it. You just push the button, and then you're going to get a digit, and then you can do it through your USB and in there. So just be careful on that, but not all of the wireless access points are going to allow that. So then we have an extender here. If you have wireless access points in your house that are not being able to be reached, you might want to get an extender to help that, especially if you're going through walls. Okay, here we have one in a building that has a basement and a concrete floor. So you can see you may need to have a bridge between the two of them, and even if there isn't a floor over here. So you can see how they are separate floors, 1, 2, and 3. If it's a basement, it could be even worse. But this one, they're going to have a wired access point that's connected to a switch. So they're actually going cable into the different floors. So here's a few things for you to look at. Here are a few items to there. Here's a few items to discuss. And that's the end of part 1. So hope this is helpful to you. And if you have any questions, as always, please let me know.